In this next section, we're going to talk about structures that have multiple methyl and ethyl groups. So in the previous two sections, we had single methyl groups or single ethyl groups. In this section, we're going to look at these structures that have multiple of either methyl or ethyl groups or both. So far, as I said, we've had just one substituent in each compound. Now we're going to address naming compounds which will have multiple substituents. And you can see here in this image, we have some branches coming off of what appears to be the main branch. The procedure here is going to be the same as what we've been doing for the last, 70 slides, okay? But there will be two differences. First of all, the numbers of the carbon atoms to which the groups are bonded are all listed and separated by commas, and then prefixes are added to indicate the number of groups of each type. For example, 2 methyl groups on a compound would be dimethyl, 3 would, so that's what we see here. Here's a methyl group and here's a methyl group. 3 would be trimethyl, 2 ethyl groups would be diethyl, 3 becomes triethyl. Okay, so as we've been doing, we'll go through several examples so we can see how this is done.
All right, here's example 1. So we need to name this molecule here on the right. And you can look at it and see that there's a couple of branches on it. All right, so we're going to use the discussion we just had about multiple methyl and ethyl groups. Now, step 1 is the same as it's always been. So we need to find the longest chain of carbons, identify it, and name it. So I'm going to start on the left and just start counting. 1, 2, 3, 4, 5. Now, I could go this direction and I would get a 6 carbon chain, but there's longer ones, right? There's this one, 6, 7, and then there's also 6, 7, 8, 9. So that's our longest chain, 9 carbons. It's right here. And a 9 carbon chain is called nonane, N-O-N-A-N-E. Nonane. Okay. All right, so you can see that carbon chain highlighted. Now the next thing we need to do is number our carbons. And here's the thing. We could start here. We get 1, 2, 3, 4, 5, and then our first branch is at carbon 5, and our second branch is at carbon 6. Or if we start from here, we get 1, 2, 3, our first branch is at 4, and our first branch is at 5. Our next branch is at 5. So what's the goal? The goal is to make sure our numbered substituents have the lowest value possible. Okay, so we're going to start from the right and go back to the left. So we'll say 1, 2, 3, 4, 5, 6, 7, 8, 9. Just like that. Okay, so here's just a summary of that discussion that we just had. With 2 substituents, the numbering begins from the end closer to either one. If we start from the left, our first substituent is 5 carbons from the left. If we start from the right, this constituent is 4 from the right. Okay, so we want to start from the right where we'll get that's closest to that substituent. All right, so you can see in the diagram in purple that same numbering that I showed you a couple of slides back. Now the next step is to identify and name the substituents. So the parts that aren't highlighted, those branches, we can see here and here. So how many carbons are there on each of those? Right? This is just a single carbon at the end of this, right? At the end of this bond, there's a CH3, right? That's what that means. And the same is true for this up here. And what is that single carbon substituent called? It's called a methyl group. Right? So you can see highlighted in green both substituent groups, and both are a single carbon branch, so they're both methyl groups. Now, what carbon are they bonded to? If we did our work in step 2 and 3, numbering and identifying, we already know. The first is carbon 4, and the second is carbon 5. So we have one bonded to carbon 4 and one bonded to carbon 5. All right, so here you see in number 4, I've circled in red, carbons 4 and carbons 5 are the ones that the substituents are bonded to. Now we need to name it. So here's how this looks. Just like in previous examples, we start with the number of the carbon that our substituent groups are on, but in this case there are 2, so we separate it by a comma. So we say 4, 5, then a dash or a hyphen. And then because they're both methyl groups, we can use our prefixes to say dimethyl, and then our parent chain, nonane. So what does this say? This says that on carbon 4 and carbon 5, we have methyl groups on a nonane chain. Okay, so 4,5 dimethylnonane. All right, so here's our summary. The molecule is 4,5 dimethylnonane. The numbers of the carbons to which the methyl groups are bonded are separated by a comma, and the prefix di is added to indicate that there are 2 methyl groups, one on each carbon. All right, so here's example 2. We're going to do exactly what we did before. We're going to follow each of these 5 steps, the goal of which is to identify and name this molecule here. So first thing we're going to do is identify and name the main chain by finding the longest chain of carbons. So if I start here, I get 1, 2, 3, 4, 5, 6. Or I can go 1, 2, 3, 4, 5, 6. Now 7, 8 this direction, or 7, 8 this direction. Okay, so 8 carbons is our longest chain. Right? I'm just going to pick that one. I could have also circled this direction instead, and I would have gotten the same molecule. Okay, I'm just picking the one that's straight left to right because it's just a little easier to then see the branches. And so 8 carbons is octane. All right, so here's a discussion of exactly that. This is octane, and we could have chosen either of these, as you see in purple highlight, as the main chain, but the resulting name will be the same. We'll proceed with both to confirm that. So I'll just show you using both that it doesn't matter which one you choose, you end up with the same molecule. The next step is to number the carbons. Remember, when we number carbons, we number it so that we get to this. We want to number on the side of the constituents, on the side that the constituents are closest to, or so that they have the lowest numbers possible. So I start on the left, I get 1, 2, 3, 4 is my first substituent. If I start on the right, I get 1, 2, 3. Okay, so 3 is lower than 4. So we're going to start numbering on this end right here. 1, 2, 3, 4, 5, 6, 7, 8. Same thing is true here. If I start on this end, I get 1, 2, 3, 4. If I start here, I get 1, 2, 3, and there's my first branch. 3 is lower than 4, so we'll start here. 1, 2, 3, 4, 5, 6, 7, 8. Just like that. As a summary, in both diagrams, one substituent is 4 carbons from the left and the other is 3 from the right. So we begin the numbering from the right, either here or here. Indicated in purple on both diagrams are the numbers from 1 to 8 that match identically with what I showed you a couple of slides back. All right, now we need to identify and name the substituents or substituents. So we can see them pretty straightforward from this one. It's just these branches, right? So here's one. Here's a second. Same thing, here's one. And here's one. And they both have 1, 2 carbons, right? 1 carbon, 2 carbons. And a 2-carbon group is an ethyl group. So both substituents are ethyl groups. Same here on this one, right? There's 2 carbons there. So same groups. So you can see in green those groups highlighted that I went over in the previous slide, and they both have 2 carbons, and so they are both ethyl groups. All right, now we determine what carbon are those substituent groups bonded to. So if we did our part in identifying and numbering, we should straightforward see we have carbon 3 and carbon 5, and just we see this is also carbon 3 and carbon 5. So they're bonded to carbons 3 and 5. All right, so indicated in red, you can see we have substituent groups bonded at carbon 3 and carbon 5. And we just identified in part 3 that they were both ethyl groups. So when we write our name, we can write 3, 5, diethyl octane. So if you do all of this one step at a time, once it gets time to writing the name of the molecule, you're in great shape. So the name of this molecule is 3,5-diethyloctane. All right, here's a summary of the work we did for this example, and the name of the molecule is confirmed as 3,5-diethyloctane. And it's the same for both of these compounds. So just demonstrating, it doesn't matter whether we start our numbering here to the left or down at the bottom and up and to the left. Again, the goal here is to just find the longest carbon chain and make sure we number it so that our substituents groups have the lowest numbers possible. If we do that, we'll get the right name every time. Another situation that can occur is when there are different substituents on the compound. So let's consider where there are 2 methyl groups. So this has a methyl group here, a methyl group here, and 1 ethyl group here. The approach is the same, but both types of groups are included in the name in alphabetical order. Okay, so ethyl would come before methyl, right? With the appropriate prefixes. The prefixes, though, are ignored when using alphabetical order. So if we had a dimethyl or triethyl or something like that, we use the methyl and the ethyl to determine our alphabetical order. So triethyl goes before methyl since the order is based on the E in ethyl and the M in methyl. All right, so in example 3, we're going to take that funky looking structure from the previous slide and we're going to name it. So identify and name the main chain. So let's start counting. I'm going to start here. 1, 2, 3, 4. If I went this way, I'd get 5. Okay, if I go this way, I get 5, 6, 7. 1, 2, 3, 4, 5, 6, 7 this way. Or 1, 2, 3, 4, 5, 6, 7, 8. So that 8 chain length is the longest. So this is octane. All right, so you can see with the highlight in purple, the octane chain identified for us. Now we need to number these carbons. So remember, we need to start our numbering on the end of the chain that's closest to any substituent. We want that first substituent to have the lowest number. If I start here, I get 1, 2, 3, 4. So I'd start with 4. If I start from right to left, I get 1, 2, 3, and I reach my first substituent at carbon 3. So that's what I want. I want the lowest number. I'm going to start from here. 1, 2, 3, 4, 5, 6, 7, 8. All right. Talk about this a little more in the next couple slides. All right, so if we start from the left, this one substituent is 4 carbons from the left, and this substituent is 3 carbons from the right. 3 is less than 4, so we start numbering from the right. All right, so indicated in purple on the diagram is our numbering from 1 to 8, starting from right to left. Now, step 3, identify and name the substituent. So I'm going to circle them. Here's one. Here's another. And here's a third. So they're not all the same, right? This is methyl. This is methyl. And this one is 2 carbons, which is ethyl. All right, so in green, I've highlighted the 2 methyl groups, and in orange, the 1 ethyl group. So now we determine the carbon to which the substituents are bonded. So we've got carbon 3, carbon 4, and carbon 5. So the 2 methyl groups are bonded to carbons 3 and 5. And the 1 ethyl group is bonded to carbon 4. All right, so circled in green are carbons 3 and 5 for the 2 methyl groups, and circled in orange is carbon 4 for the 1 ethyl group. So now we need to name the molecule. Now, remember we have methyl and ethyl. So which one comes first? It's alphabetical order, okay? So E is before M, so we name the ethyl group first. So we have 4-ethyl. We separate by a dash, and we say 3,5-dimethyl, and then our parent name, octane. 4-ethyl, 3,5-dimethyl, octane. As a reminder, alphabetical order is used to list the substituents, and the prefixes are ignored. Ethyl goes before dimethyl, since the order is based on the E in ethyl and the M in methyl. All right, here's example 4. We have a structural formula here that we need to name. So first we're going to identify and name the main chain. Now, it's a little harder to see when it's written, our carbons are written out like this, but these steps are the same. So I'm just going to start at the top and start counting carbons. So I could go 1, 2, 3. That's obviously not the longest chain, right? I could say 1, 2, 3, 4. Also not the longest chain. 1, 2, 3, 4, 5, 6, 7. That's not the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. That is the longest chain. So it's a little bit long and windy, but this 8 carbon chain is the longest one in the molecule. It's 8 carbons long, so we will call it octane. So you see highlighted the chain that I chose. There is another, like I could have started here and said 1, 2, 3, 4, 5, 6, 7, 8. That's the same chain. If I'd started it from here, you would get the same name, okay? So as long as you find and identify the longest chain of carbons, you're in good shape. The next step is to number the carbons. And so we've got to start from the end closest to any substituent group. If I start here, look at how far I have to go to get to this group, versus if I start here, it's just the next carbon. So it's pretty straightforward to start from here and say 1, 2, 3, 4, 5, 6, 7, 8. As you can see in orange, the nearest substituent from the left or the top of the molecule here is 2 carbons. And if I started from the right side, I'm 4 carbons. So we're going to start numbering here, okay, from the left. All right, so indicated in purple on the diagram is that same numbering I showed you a couple slides back, starting at the top of the molecule with 1 and going around to 8. Now we need to identify our substituents. So there are 3. There's one here, one here, and one here. So in green, these are both 1 carbon each. So those are methyl groups. 1 carbon is methyl, right? And this is 2 carbons. So this is an ethyl group. So we have 2 methyl groups and 1 ethyl group. All right, so again, you see, just summarize what we did on the previous slide. We have 2 methyl groups and 1 ethyl group. Now, what carbons are they bonded to? Well, the methyl groups are bonded to carbons 2 and 3. And the ethyl group is bonded to carbon 5. Now that we know that there's a methyl group at carbon 2 and 3 and an ethyl group at carbon 5, we can name the molecule. And remember, we do it based on alphabetical order. So ethyl comes before methyl. So just start here. Where's the ethyl at? It's at carbon 5. So we have 5 ethyl. Then we have methyl at carbons 2 and 3. 2, 3, dimethyl. And this is octane. 5 ethyl, 2, 3, dimethyl, octane. All right, here's a summary of the work we've done in this example to get to this name, 5 ethyl, 2, 3, dimethyl, octane. Reminder that alphabetical order is used to list the substituents and the prefixes are ignored. So even though it has a higher number, ethyl comes first before dimethyl because the E is prioritized here. The E in ethyl comes before the M in methyl.